All right, so let's take a look at this problem. All right, some things I'm noticing is that the probability of a single component failing is 0.15. So is it component for one, is it unusual for one component to fail? Well, because the 0.15 is larger than 0.05 or 5%. No, it's not unusual because that's not a rare event. Now, how about two components? Well, the probability that two components will fail is calculated because these are independent events. I'm just going to take the 0.15 for one component and 0.15 times the second component, and that is equal to 0.0225, which is less than 5%. So that isn't an unusual event to have two fail. Okay. Now for part B, it says what's the probability that a parallel structure with two identical components will succeed? Well, if the probability that a single component will succeed, will catch it, is 0.85. So for two of them, we're just going to square them again. And what is that? 0.7225. Okay. So now for this last one, this is getting at that at least kind of idea. So we want to know what's the probability that at least one will make it? Because if one is still working, the whole process will succeed, as they're telling us. Okay, as long as one of them is working. So we know the probability of them both failing is, if there's two components, is 0.0225. So thinking about that at least probability, and to set this up, I'll do it for this one. We know this answer. If I take 1 minus 0.0225, that's equal to, what is that, 0.9775, I think? I did my arithmetic right. So which is not good enough. So what we need to do is, well, you can always do this guess it and check in. It's not too big an answer. But really, the equation we're trying to solve is this equation. And actually, it's an inequality. Because I want this to be bigger than 0.9999. Okay, well, since inequalities, we can find the boundary. Okay, I'm going to pretend this is an equation for a minute. And I'm going to subtract 1 and then divide by -1 because it's that negative in front, which leaves me this equation, 0.15 to the n equals 0.0001. Now, you don't have to know about logarithms for this class, but if you've studied them before, the way you solve this kind of exponential equation, you can take the log or the natural log of both sides. I'm going to do the natural log. And then, so that means to find n, I'm going to take the natural log of 0.0001 and divide that by the natural log of 0.15. And that'll give me an answer. In fact, when I did it earlier, I got, what did I get? I got 4.85. So that means I would need to have at least 5 components to make sure I was greater than the 0.9999. And just as a check, 1 minus 0.15 to the fifth. That wouldn't have been that bad to check. All right, so I'm getting 0.99992, yada yada. So that does work. So it'll take 5 components to ensure that it succeeds. Okay, hope that helps and hope that answers your questions about this.